So, hello everyone, and thank you for being here. So, in today's talk, I will be talking about software development and how it's changed in the cloud era. So, just a few things about myself. As they introduced me, I recently moved from Canada to join Reykjavik University as assistant professor in the School of Computer Science. Before that, I worked in several companies at different levels and roles, starting from support and development to IT consultation, IT management, then to research and development. And before that, also, I have different background in business management, and I have PhD in software engineering. Today at Reykjavik, I run a research lab that focuses mainly in addressing the complexity of architecting software applications that should be available, of high quality, scalable, by leveraging and reaping the benefits of evolutionary technologies such as cloud computing, Internet of Things, big data, social, and mobile. So in today's talk, we'll start by this digital transformation. So today, we're living in this era of digital transformation, where the success of business really depends on its ability to transfer business into technology. And when we refer to technology, we really mean software. And if you're still in doubt of that, just take a look at the landscape of the business and most successful business companies. Today, the world's largest taxi company, Uber, is run by software. And the world's largest accommodation provider, which is Airbnb, does not have any accommodation, but it's mainly managing software. And this goes to all sectors of business. The success of these organizations mainly due to this digital transformation from business ideas to software, but it's also due to the ability of these organizations to manage these applications at scale. So if you win an election, you will not be ending searching how to run a country. And if you build your own software or transfer your business idea into a software, then you should not be searching how to operate this software. So the key there's three key elements for the success of any internet-based company or business. Those are the agility, continuity, and cost reduction. And by agility, we mean the ability of the application to change both at runtime and at design time in order to meet the customer needs. By continuity, you should keep your application available 24/7. And by cost reduction, if you don't implement strategies that can reduce cost, then you cannot keep up with the competition in the market. However, addressing these factors is very difficult, as it requires several decisions at different levels, at the architectural level, at the operational level, and at the managerial level from financial point of view. Luckily, in the cloud domain today and the cloud era, we have a combo that can help us to address this. So before we talk about this trio, let's agree first that in order to transform your business ideas into software, you need a software architecture. And in order to be able to operate and manage this software, we need technology. And in order to manage the whole process, you need a process and set of tools. So today's talk will be mainly addressing these issues. In the cloud era, we have for addressing enterprise mainly applications, there's this notion of microservices for the software architecture. And the technology that enables these microservices, usually we hear about this notion of containers and infrastructure as a code. And for the process, you hear this notion of DevOps. So this is the main topics of today's talk. Microservices, according to James Lewis and Martin Fowler, a microservice architecture style is an approach to develop a single application as a suite of small services, each running its own process and communicating through lightweight mechanisms. So if I want to use my own words to describe this, I will tell you that it's a set of guidelines that help you to develop what we call malleable application, an application that can be reused, reconfigured, recombined at runtime and at design time. And the essence of this is two main concepts: modularity and substitutability. By modularity, we mean the ability to partition the application into modules, and by substitutability, we mean the ability to reuse components and replace components. So let's see how the modularity and substitutability history affected today's microservices. So if we look at, and we start from the first programming paradigm, the structural paradigm, the main focus were to have clear applications, to improve the understandability. And for that, the main goal was to decompose the application into functions or subroutines and manage the control flow between these subroutines. So what's the problem in this approach mainly is that all subroutines and all functions have access to the same data. So we have this global data like a notion which affect reusability of the application. In order to address this, the idea was to hide this data within these what we call objects and encapsulate the functionalities with the data. And this provides us with good solution. But the problem was that object-oriented and objects in general, they're technology and language-oriented. The class diagram represents the data structure of the system. And the object model represents the state of the program itself. Moreover, the fine-grained components of these objects, in addition to having single interface for communication, as the program becomes larger, this becomes a problem. The objects become chatty, and we end up with what we call spaghetti code. So in order to address this, the goal was to having a coarser-grained components. And this is the notion of component-based applications. In component-based application, the focus was to partition the application based on business orientation. So business functionality rather than the technology. Moreover, these components need to have clear interfaces, provided and required interfaces in order to communicate with other components. This notion of component-based applications was the first step toward better substitutability. And this was the long dream that had been accomplished through a number of steps. The first step was through this, what we call the enterprise application integration and the broker models, where you have component frameworks like Corpa that enables you and provide you with all the tools and technology required to do the plumbing work of connecting the components, and provide also languages in order to identify the interfaces and specify the contracts of these interfaces. Now, this was the first step. The second step was to focus on standardization. And this is what we call the era of standardization, or what is known as service orientation. At this stage, The focus was mainly to standardize everything. Standardize the way of communication by having standard protocols for like HTTP. Standardize the way we specify messages, such as having SOAP as envelope. Standardize the way we communicate with the broker model in order to have to know about what the provided functionalities by each services and the required functionalities by each service. And this is through what we call the canonical model of exchange formats. We start using XML files and other markup languages. But still, we have a problem. With this enterprise service bus in the middle, we still have single point of failure somehow. We still need to connect everything to this enterprise service bus. So is there a way to make these components communicating directly with each other? So there is one other step and one further step of standardization that we need. And this was fielding work, which is what we call today by the REST architectural style. So with the REST architectural style, we not only standardize all the other things, so all other things will stay the same, but we also standardize the way we provide the functionalities. So the service will know ahead of time what other functionalities are provided by other services, what are required by other services. It's a standard functions: get, put, post, patch, delete. So this way, by having this notion of REST and the REST architectural style, you don't need to have this broker model. And this is essentially where like microservices emerged from. Today, when we talk about microservices, we talk about componentization around the business model, try to decompose and partition your application based on business functionalities, and we talk about communication through lightweight mechanisms such as REST. Maybe the only thing that we are more pushing toward these days is having more smart endpoints by using agent models and things such as actor models, but still, this is also there for a long time. So the takeout, there is 3 golden rules for microservice architectures. The first one, I call it, have a good sense of boundaries. And by boundaries, we mean business boundaries. And in this, if you really like to investigate this field, there is the domain-driven design development. I feel that is well established, that focus on avoiding functional partitioning and focus on practicing subject matter partitioning, which is partitioning based on business functionalities and team size. So if you need to know more about this, read more about domain-driven design. The second rule is no sharing, else cap caring. And by cap, I refer to the cap theorem: consistency, availability, and partitioning. So the golden rule here is that if you can partition your microservices in a way that you have one storage per service, then this is fantastic. But this is not always the case. Most of the time, you will have to have shared database between the different microservices. And in this case, you need to address the consistency, the availability, and the partitioning. Mainly, you should focus on how to have strong consistency and how to have eventual consistency. And this can be achieved by first identifying the transactional boundaries, use separate schemas, and use other patterns such as the CQRS, command query responsibility segregation, or using eventual event sourcing frameworks. So I threw several concepts here, and I call you, because of time, I call you to go and investigate each of them if you want to have no sharing of cap caring. So the third one is to master the art of communication. And by this, we mean that microservices need to communicate through this endpoints, smart endpoints, using lightweight mechanisms such as REST. And you have also to perfect your case by keeping your messages short and simple. So we talked about microservices. Now the question is how to ship these microservices, how to ship these applications into the operation site. In order to ship these operations, like the microservices into the operation site, we mentioned that microservices will be built on different technologies and based on different development frameworks. You may have like 2 microservices, each of them developed using different development framework, and you want to ship these to the operational environment, which is the remote server or the cloud. In order to do that, there is several approaches that can be done. One of them is just to encapsulate everything, take a snapshot of it as a virtual machine, and host this virtual machine on top of the like remote server. The problem with this approach is that it's like whenever you want to download a new game or a new application in your mobile, you need to download also the operating system and install the operating system with it, which is like heavy, time-consuming, resource, like does not have resource efficiency, and you are also putting an operating system on top of another operating system. So the solution here is to, instead of doing that, is to use containers, which are user space instances or processes, which is the big new thing, right? Well, not really. If you ever create a new user or a new user profile in your operating system, then you're creating this environment or this user space process where you have the data, your programs, and it's not shared with other people, and it's also providing you with with your own data libraries. So this is the same notion, and if you even read what is user profile, it's even the same notion of what we call today by containers. So what's new about these containers? Why all this hype about containers? The hype about containers coming from the tools that is now available for what we call Buddha tools. Package once, deploy anywhere, such as Docker and Rocket and other tools. These provide convenient way of packaging and shipping around the application and all its user space dependencies, libraries, and application data. So now you don't need to ship the operating system with your application. All you need is to ship the application and the libraries, and the container technology will take care of the interaction between the operating system and the input-output. So what's the advantage of this? Of course, portability. Operational efficiency, so we can now, each of your microservices can have its own resources dedicated to it, because we can have fine-grained decomposition of resources, the CPU and RAM, and it's lightweight and faster because we don't ship the operating system. Productivity, because we don't need, like the developers will not focus on what the remote server need to be equipped with. And the most important thing is version control. You can build this manifest file once and push it to the repository or the cloud, then other people can reuse it. You can also have, in any case you want to roll back to previous version, you can roll back to previous version, which is very powerful thing. So where we're shipping these containers, we're shipping them to the cloud, mainly because we want to reap the advantages of scalability, availability, cost reduction, as we mentioned before. And when we talk about the cloud, what's the main advantage of the cloud? It's this ability to provision resources in demand in an easy way. And this mainly empowered by what we call infrastructure as a code, which is a new way to provision and manage infrastructure that depends on virtualization, automation, and templates. The virtualization, such as containers or virtual machines, mainly containers now, allow you to scale the application in seconds. The automation, which is based on autonomic computing, so when we hear now Cloud Fabric, it's autonomic managers that allow you to take these rules, whether it's constraint rules or active rules, and act upon them, which will relieve you from the complex capacity planning. And most importantly, these templates. The easy way, nice way to communicate with the autonomic manager. So you can communicate easily. You have better documentation for your infrastructure. This infrastructure now become an asset. You can push it into source control, and you can have version control of this. You can roll back, so you can reap all these benefits. So we talk about microservices, containers. What about this DevOps? So we mentioned at the beginning that there is complex decisions that need to be done. And these decisions can be architectural decisions, operational decisions, and financial decisions or business decisions. It's difficult to communicate between the different teams. So is there a way to have better communication between teams? And this is the essence of DevOps. It's a culture that is based on this, facilitating this way of communication, facilitating collaboration between the different stakeholders at the development side, at the operations side, in order to be able to bridge the gap between them, to not override the same decisions again and again if we need to do or incorporate some changes. So this is the feedback. So I will leave you today at the end of this talk with this mandate by Jeff Bezos, the CEO of Amazon, which believed that between 2001 and 2002, he circulated this mandate to all the employees in Amazon. And it's believed somehow that these rules and mandates are the reason behind the success of Amazon today. If you read these rules or these mandates, we see that it's mainly about our lecture today. All teams need to expose their data through service interfaces. Teams need to communicate, which is the essence of DevOps. Communication should be only through interfaces, the essence of microservices, technology independent, with the essence of containers, and also partitioning based on business rules. And most importantly, he went even one step farther by saying anyone who will violate this, he will be fired. I will not tell you that you will be fired today, but I will tell you that a wise person is someone that also benefits from the experience of others. So if you have an application that needs to scale at runtime, that need to scale to accommodate large number of customers, then you should think about this mandate. Thank you, and have a good day.